Image degradation, that is motion blur, focus blur, resolution. The inverse filter, the linear filter, map formulation. In contrast to image enhancement, in image restoration, the degradation is modeled. This enables the effects of the degradation to be largely removed. Degradations: original, optical blur, motion blur, spatial quantizations, discrete pixels, additive intensity noise. Overview: deconvolution. The objective is to restore a degraded image to its original form. An observed image can often be modeled as g of xy equal to double integration h of x minus x dash y y minus y dash f of x dash y dash dx dash dy dash plus n of xy, where the integral is a convolution. The integral is the convolution. H is the point of spread. Where integral is the convolution. H is the point spread function of the imaging system, and n is the additive noise. N is the additive noise. The objective of image restoration in this case is to estimate the original image. Estimate the original image f from the observed degraded image, g degraded image g, degraded image g, f from the observed degraded image g. Degradation model. Model degradation as a convolution with linear, shift, invariant filter h of xy. Example for out of focus blurring, model h of xy as a Gaussian. Original f of xy convolution with, that is f of xy original convolution with h of xy, that is 1 by 2 by sigma square e power minus r square divided by 2 sigma square. Then g of xy, that is getting blurred image. That is g of xy equal to h of xy convolution with this one h of xy convolution with f of xy. H of xy is the impulse response. This is the impulse response or point spread function of the imaging system. Point spread function. Here actually what there be 1 by 2 by sigma square e power minus r square divided by 2 sigma square. That's all. The challenge is loss of information and noise. Loss of information and noise. Gaussian, that is Fourier transform, getting here. Blurring acts as a low pass filter and attenuates higher spatial frequencies. Gaussian scale 3 pixels. Fourier transform here, and then inverse ft. This ft multiply with this Gaussian scale 3 pixels, then get inverse ft. Blurring acts as a low pass filter and attenuates higher spatial frequencies. Definitions: f of xy equal to image before degradation, true image. G of xy, image after degradation, observed image. H of xy, degradation filter. F cap of xy, estimate of xy, f of xy computed from g of xy, n of xy additive noise, f of xy degradation, uh, degradation, that is giving h of xy, n of xy, then g of xy from degradation, then given to restoration, then restoration output f cap x comma y, g of xy equal to h of xy, conversion with the f of xy plus n of xy gives to g of uv equal to h of uv f of uv plus n of uv. The inverse filter. Start from the generative model. G of xy equal to h of xy conversion f of xy plus n of xy implies g of uv equal to h of uv f of uv plus n of uv, and for the moment ignore n of xy, then an estimate of f of xy is obtained from f cap of uv equal to g of uv divided by h of uv. Restoration with the inverse filter, g of xy given to Fourier transform ft, it gives then output g of uv, it give to inverse filter, that output f of f cap of uv, then it is give to inverse Fourier transform, then f of xy, f cap of xy available. Here g of xy, f cap of xy. 1D vector explanation. G equal to h conversion f, gn equal to 1 by 4 fn minus 1 plus 1 by 2 fn plus 1 by 4 fn plus 1. Here g1 equal to 1 by 4 f0 plus 1 by 2 f1 plus 1 by 4 f2, g2 equal to 1 by 4 f1 plus 1 by 2 f2 plus 1 by 4 f3 for n point ignoring boundaries. G equal to AF, where G and F are n vectors and A is an n cross n matrix. Hence, ignoring possible problems if A is singular, F equal to A inverse G. Here, Fourier trick, G equal to H convolution F, G equal to HF, F equal to G by H, F equal to IFT of G divided by H. Example, deblurring. Example of deblurring deconvolution. Image blurred with Gaussian point spread function. H of xy equal to 1 by 2 by sigma square e power minus r square divided by 2 sigma square. That is f of xy. N of xy normal distribution mean 0. Here g of xy, this is the g of xy. Blur sigma equal to 1 pixels, 1.0 pixels. Noise sigma equal to 0.3 gray levels. Restoration with an inverse filter. F cap of u comma v equal to g comma g of uv divided by h of uv, where h of uv is the ft of the Gaussian. Deblurring with an inversion filter. Noise equal to noise sigma equal to 0.3 gray levels. F cap of uv equal to g of uv divided by h of uv. Blur in the g of xy, blur here sigma equal to 0.5 pixels. Here blur is sigma equal to 1 pixels. Blur sigma equal to 1.5 pixels. F cap of xy equal to same like this. Okay. Model, for example, image 1, original images, Wiener filter method, regulation filter method, Lucy Richardson filter methods. Image 2, same, here only different. So in image 3 shows like this. So blur image model showing original images, Wiener filter, regularization filter, and Lucy Richardson filter. Lucy Richardson's filter method. So this is the among these. This is the original image. So here is the different for Wiener filter, regularization filter method, and the Lucy Richardson method. Here regularization filter method is the different. Here advantage is the shadow is there. Here no shadow. That much this much. Here no shadow. Okay. In same original images, Wiener filter, regularization filter method, Lucy Richardson filter method. Here in image 1 shows here image 2 unblur image model. This is blur image model. This is unblur image model. Unblur image model. Unblur image model showing original image, Wiener filter, regularization filter, and Lucy Richardson filter. Here, in image, Wiener filter, regularization filter, Lucy Richardson filter. Comparison performance parameters of blur image after restoration. Image 1 22.18 here. Image 1 for Wiener filter BSNR, SSIM, MSE. Compared to other, here BSNR 24.45 more than this. Here 2200 sorry here 29.58 in Lucy Richardson filter. So like this comparison of performance parameters unblur image after restoration. Image 1, image 2, image 3. This is Wiener filter for PSNR value, SSI value, MSC value. For regularization filter, BSNR, SSIM, MSC. Lucy Richardson filter, BSNR, SSIM, MSC. Here for BSNR calculation, here for image 1 20.23, here 11.45. So here 24.58. This is the higher than Wiener filter, regularization filter. Here SSIM also here 0.48, 0.78, here 0.22. Here image 3, this is the image 3. Here unblur image after restoration. Unblurred image in Wiener filter. This is the Wiener filter. This is the regularization filter. This is the Lucy method. In Wiener filter, image 3 BSNR value is 15.2. Here, very less BSNR. But here, 45.23. This is higher than this, 45. Here, BSNR value 20.770. Though this is higher than this, that's why we are getting better than original image also. For 2 unblurred image model, in here image 2, here 17.45, here in